Hello, everyone. Thanks so much for joining us at Code Talks at Domi Station. Once again, we are back talking about HashiCorp tools. This is the Tallahassee HashiCorp user group quarterly meeting. Glad you joined us. Today, we are actually going to talk about a community project from Nunchi Studios called HashiBox. Lots of times folks will ask, hey, how can I get started? It seems like, the HashiCorp tool suite is product suite is designed for, really large, robust use cases. And, um, you know, how do I get going on my local development environment? Just to kind of take things for a spin, kick the tires and see what it looks like to work with the HashiStack. So happily, the good folks over at Nunchi Studios have created a community project on GitHub called HashiBox. And I am going to show it to you here real quick. This is their GitHub profile so that you'll know you're in the right spot. And right here in the about, it pretty much tells you everything you need to know. It's a Vagrant environment configuration that simulates a highly available cloud with Consul, Nomad, and Vault. OSS and Enterprise support are both supported, and it has optional support for Waypoint. So scroll down a little bit further. They've got a great README that'll kind of talk to you about, what's gonna, what goes on, what their design goals were. They've got getting started links, a little bit of, foundational knowledge you need to, know about whether your environment can run this or not. But if you're on a Windows machine or a Mac, if you've got Parallels, VirtualBox, or VMware Desktop, you're pretty much good to go. M1 Max might be a little bit of a problem right now, but other than that, you should be good to go. You could make that work with QEMU if you really wanted and you were industrious. So what they are basically putting together for us is an environment that looks something like this. They have a makefile included. You run the makefile. It spins up some Vagrant machines. It uses Bolt then, which is a command line utility from Puppet Labs, to do some post-provisioning of the environment once the Vagrant machines are spun up. And once they're up and running, what you end up having is oh, hey, Charlie, welcome. Thanks for joining us. I see we've got a friend who's joined us online, another Hashi corporeal. So once the Vagrant machines spin up, you've got a cluster of machines running virtually on your host that looks like this. You've got 3 servers with well-known IP addresses that can interact with the host operating system. And then you've got 3 servers that are clustered together. Each one of those is running Nomad and Consul and Vault. And they're all automatically interconnected and joined together and interoperating the correct way. And then you've got 3 clients that are also spun up, and you can modify the Vagrant file to your heart's content. You could set up a one, and we'll talk a little bit about this later. You could set up a 1 server cluster or a 3 server cluster with 6 nodes. Just depends on or 6 clients. Just depends on what your machine can handle and what your use case demands. But this is the basic setup that comes by default with the configuration included. And then they give you some handy screenshots about what things will look like once it's up and running so that you can know your setup is correctly configured. And it's for each one of the tools. And yeah, it's pretty sweet. So, and then of course, let us not forget Waypoint. Yeah, so really well done documentation, really well done user experience or developer experience in this case. Kind of gives you the shortcut keys to the kingdom of how do we get things running quickly inside the inside the a local development environment, and then sort of get yourself oriented with the entire way the Hashi stack can work. So real quick, I'm going to open up. They added something new since the last time I've been here. So I'm going to go off stack, or off script rather, and look at this. They seem to have added. Oh, look at that! They added a whole like a vanity site that explains things a little bit better. And so yeah, there you go. Kind of walks through what we just talked about. Pretty interesting, pretty cool that they did that. I bet you they're getting started is going to take us to where I was going to show you. Yep, here you go. This is how you, it's going to give you an overview of the infrastructure that they are going to, configure for you. They're going to simulate something that might look like it's running in AWS with a US West 1, a US West 2, a US East 1. So they've got different availability zones sort of emulated and configured, the regions in the different tools. And then they give you kind of a walkthrough of what's going on in the repository, which is part of what we're going to do tonight. And then the installation is pretty cool. It's pretty straightforward. All of this is just sort of background, go set these environment variables so things will run right. You can tweak your configuration. So for instance, if you're using parallels, you're going to want to set, in your ZSHRC or BashRC or whatever, you're going to want to, or even just a moment, ephemeral terminal session, you're going to want to set which provider you want to use, and then the Vagrant file will pick that up as an environment variable. You're going to set which, Ubuntu version you want, how much RAM you want for each client machine, how much RAM you want for the servers. And then if you're going to use an enterprise version of the software, then you do need to provide license keys as environment variables as well. And then the Vagrant file will just pick that up when it provisions the environment and configure everything dynamically the way that you have configured your environment. So again, you could use VirtualBox, which is what I do. You could use VMware Desktop Parallels. Let's see. We talked about all that. Okay, so now here's the thing that I think is super cool about this setup. If you just download the repo, you just set those environment variables, and you make sure that you've got VirtualBox or VMware or whatever installed, you can literally go to the root of the repo and type make init, and you will, in a few minutes, well, let's be honest, it's a little more than a few minutes because it's going to have to provision 6 Vagrant machines. You can type in make init, let's say it's a Saturday morning and you're wanting to tinker around. You can type make init, go brew a pot of coffee, pour your first cup, come back. It might be done, it might not, but when it is done, you will now have a simulated cloud environment that you can spin up and down in less than a minute, that you can work with once that initial provisioning takes place. And why does the provisioning take so long? Well, things have got to go out and download the internet and update security patches and all of the things, right? But they've done a fairly decent job of trying to keep the base box image up to date. But and they are constantly iterating on this, and so I got to give them big, kudos to the Nunchi Studios group for definitely iterating on this and constantly improving it and doing right by the community with it. And then, so once that initial VM provisioning via Vagrant takes place and things are up and running, you can verify your installation by sort of, just going to the service pages. So I actually went ahead and turned my environment on a little earlier, and my environment's a little specialized because I actually developed these tools. But you'll see a bunch of output like this coming on the VM when you get once you've run make init, you then want to run make up, right? And that's just a target in the make file in the root directory of the repo, right? Now I've already run make up, and so it's already provisioned my stuff. I could run make halt, and that would be a shortcut for vagrant halt, and that would just kind of, you know, bring things down or suspend the machines. I still have my vagrant commands available. I could just do vagrant status, and then we will see that there we go. We've got 6 machines running, 3 servers, 3 clients. I can do, I've got my, I work on Nomad, so I've got my environment variables set up. I can run Nomad node status and Nomad status, and boom, there you go. It will give me back information. So I've got a cluster running and healthy. But the getting started documentation will kind of walk you through is actually going to the UI. So for Nomad, that would look something like this. And I've got this job running, and it's got a depending employment, whatever. That's where I left off before we started the demo. Now I could also go to, let me remind myself. Yes. Let's go to 8500. And what do I see? Voila, I see the console UI. And I can see any services that I have running or not running. I can see the nodes that I have. If I'm adding any key value, I can come in and, so I've got a fully functioning console cluster here as well. And that's pretty cool. And I can manage it through the UI or through the CLI. So then what if I go to 8200, this port on the same machines? Well, voila. I have, I've got a vault setup that I can interact with. And the installation instructions will tell you how to download your root token and things like that. It's really conveniently set up. You just basically have to, I don't even know how to tell you. It's virtually turnkey, and the installation instructions are very well written and very easy to follow, and they will give you lots of visual indicators that you have done the right thing or not, and then even give you some clues about where you might want to go back and rework your stuff. So yeah, this is a pretty amazing setup. Vault initialization is the one thing that you still kind of have to do. You have to unseal the vault servers in order for everything to work as expected. And that's it. After make up, you go to this step, you follow the instructions, copy the token, unseal the keys, or unseal vault rather, and call make sync, and everything gets restarted and all the services run. It's really, really, really well written documentation. And one of the things that I find so appealing about it is that it's like, okay, well now I've got everything up and running. How does it all work? Well, let's talk about that. Actually, I'm going to pause right there and ask anybody have any questions, anything going on in the comments. All right. Not seeing much. All right. Okay. So I'm going to move on to, well, how does it all work from the inside out? So this is great. Thanks, Derek. You showed me a great way to get started, how to go past getting started. Well, let us talk about that. What I want to do is bring up a new VS Code window. So I've got the Nomad forked, or I'm sorry, pardon me. I've got HashiBox forked, and I've got it on my own site. And my interest for it came around came from being able to use it as a development environment on Nomad, where I was running in more than just the Nomad agent dev mode. If you're not familiar with it, most HashiCorp server products have an agent dev mode, where an agent will run as both a client and a server for development purposes, or for taking it for a test drive. No state gets stored. Things don't get persisted to raft on disk, etc. Everything's in memory. Um, uh, but sometimes you want an actual cluster to see how things behave when you have things, when communications are flowing across a network and there's latency and so forth. Oh, good. Charlie says he's boldly attempting to break the world by using HashiBox with vagrant QEMU provider. We shall see. Super. I was just talking about that actually right before you joined, or maybe you heard me talking about it. I think you're hacking on that this week, are you not, Charlie? Getting vagrant working with QEMU. We're all have our fingers crossed with bated breath that you will solve the M1 problem for the internet. Our friend Caitlin is definitely interested in the outcome of that experiment. So anyway, let's get back to this repo for a second. After celebrating Charlie, yeah. So what does this repo have in it? Well, there's some things that this is basically the repo as it comes, but with my modifications so that I could develop Nomad, recompile, rapidly spin up a test cluster on actual VMs, actually interacting with each other over network, rather than just a standalone agent that's acting in both modes. Sometimes it's just things just behave differently in reality versus an idealized development scenario. So how does it all work? Well, they've got something pretty interesting here in their this folder called uploads. If you go look at it, it's got some interesting folders, subfolders. One's called defaults, okay, and then there's one that has a name of each one of the regions that we highlighted in the documentation a few moments ago. So that pretty much you might suspect, and you would be right, that defaults has things that get applied everywhere, and then the region-specific naming directories has maybe config or whatever that gets applied on a per region basis. So if we look at defaults, we have a client folder. We've got one for console. We've got one for Nomad. And console has a config folder, and it's got a defaults directory, and voila, it has a basic Nomad agent config for a client. It defines the data directory, says enable the UI, servers equal to false, sets up a retry join block with all the an array of our server addresses, gives it a service name. And then it also defines a systemd file, unit file for us that is going to get pushed out to the client node and then registered. We'll look at that here in a minute. Something interesting else to point out is they're going to create an environment file in this location. They're going to expect the binary to be located at this location. And then when they start it, this is the startup options they're going to give it. And they're going to say, hey, go look at, go look at this defaults HCL that we just looked at. But then there's also going to be an overrides HCL that gets dropped into the same folder. And those two, just if you're not familiar with the way HashiCorp agent products work, if you have a configuration folder with multiple HCL files, they will get merged in lexical order. So you can sort of split your config for different parts of the agent into different files, just to keep it neat and tidy, so you don't have one huge file. And they would just sort of get smushed together at runtime, or you can also, you can put a config dir here, or multiple config files, and they've opted to do multiple config files, and I think it's because they're using separate subdirectories here. So interesting. So yeah, so this defaults file is going to get pushed up to each server in a well-known location for console. The console system D file is going to get, unit file is going to get pushed out, And then Nomad has something just like that, right? It's going to define the data directory. We're looking at a client's config. So clients are going to be true. It's going to have some config for waypoint, telemetry, basic enabled plugins, yada, yada, yada. So that's pretty cool. And then I added, because I was messing around with ACLs, I added the ACL stanza. Their documentation says, hey, we don't turn ACLs on by default, but if you want to add it, go, feel free to do so. And if you can make it generic enough, please submit a PR. So, and then they've got a similar Nomad service file. So that's pretty cool for the client, as you can imagine. And this is all the defaults. And then, server, I won't belabor the point, but it's the same sort of setup, right? Here's our default console server config, our default Nomad server config, and then systemd files. And then in the case of the servers, there's also some Vault config that needs to go because we don't have Vault clients. We just have Vault servers. It uses console as its backing store, gets a systemd file. And then because they're trying to simulate like a more cloud native environment, they've gone ahead and said, okay, well, 60 and 61 are going to be in US East 1, and then oh wait, did I forget how they did the IP splits? Oh, it's on the last one. Sorry, it's 30. So the .31s go in US East 1, the .10s go in US West 1, and the .20s go in US East 2. And then there's the same sort of folder structure. In this case, it has an overrides file, and it just does the configuration that's specific to that in client in the overrides area. In this case, the data center is US, and so on. So that's pretty cool. I really like the way they sort of made a composable setup here. And then, so how does all that get, okay, so you spin up the servers, like what actually happens? What makes the magic happen? Well, they have a make file, right? And we talked about that before. So let's go look at that make file and let's see what make init does. So make init, remember, if we go back all the way to the beginning of the video, its job is to bring up the Vagrant environment. The Vagrant file is, basically a do loop that creates 3 servers, another do loop that creates 3 clients. It injects the different environment variables we talked about at the beginning when it boots them up, and voila. I've added one extra thing here that might be interesting for people who are trying to use this for development. I've defined a Nomad source and Nomad ent source environment variables in my environment, and if those are present, I will mount those into using synced folders into the VM, and that's how I can work in the IDE on my host machine, and then recompile on the target machines, and keep everything in sync and just sort of work with the environment. So let's go back to the make file. So the make file, make init, is a shortcut that basically says, okay, I'm gonna create Vagrant. I'm gonna do Vagrant up. I'm gonna pass it whatever the environment configured provider is. Then I'm gonna run these 3 scripts. Well, what do those do? Let's go look at scripts uploads. So this is the bolt command. It issues a bunch of bolt commands. Let me quickly show you bolt by Puppet. If you're looking for it, it will look like this. If you get to something like that. By the way, I love their use of the Nomad green. They definitely want to be part of the community. Thank you. Thank you for the homage to the Nomad green. Yeah, so basically it's a pretty sweet tool for, kind of post-provisioning stuff, running commands. It has a whole module system that HashiBox uses. I'm not going to go into that deeply tonight. Once I got into it and started working with it, I found it simpler for me to just write script files that do basic bolt commands. So something like this, both, we were on the upload. So the first thing it does is it creates a folder at the root of the hard drive called HashiBox, and it just starts pushing things up. It uploads these default files that we talked about to a well-known location. What does this targets servers stuff do? Well, I'm glad you asked. Over here, they provided us with an inventory file, and I modified mine to make it because I'm doing extra different use case scenarios. Sometimes I want US West 1, US West 2, US East 1. Sometimes I want DC 1, DC 2, DC 3. So I've added some stuff to the inventory here, but they're all but basically what they are is the inventory says, hey, let me define a group of servers. I'm going to give them a name called servers, and the targets are going to be the .60.xx machines, right? And then let me create another group called clients, and the targets are going to be the .61.xx machines. And so then when I run my upload script, I can say to Bolt, all right, I want you to upload this file, and then the target would be everything in that inventory file that's in the servers group, and then run as root. So that's pretty cool. It has a bunch of other built-in commands. Feel free to go look at the Bolt documentation for their specialized commands. Simple use cases like SCP, et cetera, they just kind of have, Bolt file upload. Just deal with that, right? But if you want to run sort of one-off or specialized commands, you can just do Bolt command run and then inject your, inject your bash right there. You will have to worry about escape characters and things like that because it is gonna, pipe it through. So be careful, but I'm sure you're all used to that. So yeah, this goes out and it uploads our defaults and our overrides to each one of the machines. Pretty cool. So let's go back, and then that way we know that console config got deployed, nomad config got deployed, vault config got deployed. But what I found to be the most valuable thing about all this is one of the hardest things to do when you're trying to use such complex systems is figure out how it all fits together, right? Like, how do I get console talking to Vault, and how do I get Vault using console as a backend, and how do I get Nomad to use console and Vault, and how do I make servers join each other in the right bootstrap scenario? How do I get clients to join servers correctly? This gives you a reference implementation for how all of that works, and within a very short amount of time, you kind of can get a quick lay of the land of, oh, okay, I get how this works. This is how I would run, a set of servers, and then I just amplify, right? And and then from here you could look at this as a blueprint for, oh, well, this is how I could design my Terraform to actually go provision this on actual cloud infrastructure. But in the meantime, in my local development life, I can have it running here locally, deploy my apps locally, and give it a test drive locally before I have to get to that next step. Yeah, so just want to take a pause for a second and acknowledge that that is probably the biggest value add of this tool. And I just want to give a lot of praise to the folks over there at Nunchi Studios for the work they've done on this and on maintaining it, keeping it up. It's great stuff they're doing for the Hashi community. Can't say enough. So, all right, shameless adoration or adulation over. Let's go see what happens next. So after we've uploaded that config, that again is in the uploads US, these other subdirectories don't come by dev environment, multi-region, ignore those. They're just things I've been doing for local testing. US is the one that comes by default. So just a reminder, that's where your config's at. So once it's uploaded that configurations to the servers, it's going to set up the environment. So let's go see what .env does. .env, and I think there's actually a newer version that I haven't synced with yet in the upstream. But long story short, it's going to go create that .env file that we talked about at the beginning, that the systemd files reference. Everybody remember that? It's going to, if one existed before, it's going to remove it, and then it's going to recreate it. It's going to do that to everything in the US region. And then if your local development host has the Consul HTTP token set, it's going to echo that out and use T to write it to your .env file, and then just do that again for the Nomad token, the Vault token, the Consul license, the Nomad license, the Vault license, etc. So as long as your local host machine where you're running all this from has the necessary environment variables to give you secure access, then you're good to go. And that all gets written to the .env file. That all gets fed to systemd. So we'll see here in a minute that a lot of these scripts will, when it mutates the environment, it'll drop, use systemctl to system control to, stop Nomad, stop Consul, stop Vault, then restart it. Maybe it'll resync and grab your environment variables again from the host, reapply them to the environment, and then spin the systemd services back up. All right, so that's what the .env file does, and that's pretty cool. And then install sh. What does that do? Oh, now we're going to get into the modules. So it runs these Bolt modules, and it's going to say run the install plan on server and the client nodes. So what are those? Well, if you go look underneath the modules folder and you look at server, you'll notice it says it runs the install plan. Well, under server, I've got server, I've got install, I called it a plan, so I'm going to go look at the plans folder. And voila, there's something called install. We've got install JSON, which looks like some metadata, maybe some parameters if you needed them, but we don't have any. So this is almost like an args that get fed to a PP file. Oh, what's this PP file? Well, first of all, I need to go find a Visual Studio Code extension so I can get better coloring and IntelliSense from this. But let's see. What does this do? So it looks a little bit like a function, maybe a special, like a DSL that they've written for themselves. So I've got a plan called server install. It's like server's like a namespace, I guess, for plans, because you'll notice we've got an update over here. So that's interesting. And then it has a target spec of targets. Well, that's interesting. What did we do over in? All right, let's pin this so it doesn't shut down. Let's go back over to install sh. Pin that. Oh, look, we passed targets of servers. Cool. So our targets came in. That's the target spec. What's it going to do? It's going to update packages and install a few requirements. It's going to run a task called server refresh, another one called server prepare. Whoa, what is that? Oh, look at that. We have a tasks folder. Interesting. So server refresh. So we got a refresh JSON. Yep, just what I thought. Metadata, not much going on there. Well, that's not true. Hold on. There was private is true and supports no ops true. All right, still feels like runtime config to me. And then refresh sh. Okay. It just runs apt get update. That's a lot of indirection for that. And so when I started digging into this stuff, I was like, man, I can just do that with a bolt command run. And I ended up going that way. I suspect if you had like highly complex scenarios, let me stop for a second. This is kind of a highly complex scenario but it's also made pretty simple. So I guess I can see scenarios where I'd want to go this deep and create this kind of a thing. But I don't know. Maybe there's, I haven't pushed the limits on this part yet. Maybe you get some sort of like retry, or if this one fails, the next one can go. I haven't pushed the boundaries, but it'd be interesting. If anybody out there does, let me know. So to go back to our install pp, it calls refresh, which just update apt update, and then it calls prepare, which is going to do what? Install some base foundation stuff. Okay, so they're kind of like giving you like this pipeline mentality, right? Like first you want to refresh something, then you want to install, update or make sure your base dependencies are there. All right, that makes sense. And then what does it do? Calls install. Oh, console install. Interesting. Well, where is that? Oh, voila. Console has some tasks defined. Okay, so it's all about, all right, I get it. We're getting into some code organization here. But again, it's a bash file, basically. It's a way to run a bash file. Keep your bash files separate instead of being massive inline monstrosities. So, I'm down with that. I can get on board with that. Pretty cool. And so then it does the same thing for Nomad. And I'm going to show you Nomad because I work for Nomad. And hey, gotta show our install script just because it's ours. All right, this goes out. And what's great about all this, what's really great about all this is, like, if you need to go set up a Nomad environment, if you need to go set up a console environment, you kind of have a blueprint about how to get started and the things you need to consider, right? So just hammering home that idea. So going back to our install, okay, it's gonna do the same thing for Vault. Okay, fine, I'll look at Vaults too, because hey, no disrespect to the Vault team, they're rad. They're gonna do a bunch of update stuff and install stuff, and that's cool. All right, let's close out some windows. Okay, so it installs console, Nomad, and Vault, and that's how it does it. Oh, and it's going to call reload, which is going to do the systemctl magic we talked about before. All right, that's pretty cool. And then it's just going to echo a command back. All right, that's pretty rad. So that's what install sh does. So that's how it boots up the entire environment for you. So then let's look at this. Up, make up. This is our make up target. What does it do? Calls Vagrant up with the correct provider, refreshes the environment just in case you changed it on your local host. So beware of that. Like, your host will be reflected into the target, the virtual environment that's running, unless you, I suppose you could pass overrides to make. So if you need to, not that I've ever had to do that. I've totally had to do that. And then what do we have over here? Restart. Ooh, restart sounds familiar. I think it's just going to do a systemctl restart. Yep, it's just what it does. And it does it sort of the poor man's way, right? Just goes to bolt command run system CTL restart, blah, 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 on servers, on clients, restarts, and then restarts Docker. So that's cool. So just be mindful that all your services will be restarted for you. It's going to sleep for 5 seconds, and then it's going to call unseal. Unseal was a recent addition. Somebody, one of the HashiCorp SEs actually added this after I started working on this, and I ended up pulling in the upstream templates changes because this was so useful. He just added this nice little script that'll go in and unseal everything for you with just a few lines of bash. So that was sweet. So what else we got in the makefile? Halt, pretty much just a shorthand for vagrant halt. I guess it's a few less things to type. Restart, halt, and then up. I like that. I never used that one, honestly. Forgot it was there. Destroy, halt, and then destroy. Kind of makes sense. Sync is a shortcut to synchronize the local uploads directory with the appropriate target nodes. Blah, 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 blah. One thing I will tell you. So let's back up to how I use this, how I mentioned earlier that I use this as a development environment myself. I've done some things that I regret. No, I'm just kidding. Just kidding. I've done some things that were use case specific. And what I did to sort of not, I wanted to do things in a way that was unobtrusive, or I ultimately would like to contribute this back upstream because I think you could use some of the changes I've made or better versions of the changes I've made to work with the HashiBox setup, but develop either console or Nomad or Vault, and sort of have a universal development environment. Or maybe you want to replicate your production environment and you're like, hey, I want to run console at this version and Nomad at that version and Vault at this version. So I did some experimentation around that, and but I wanted to do it in an unobtrusive way so that the changes I made could get potentially merged upstream without really breaking or adding conditional logic to any of the mainline feature set, if that makes sense. So my current incarnation is that under uploads, I've got some alternate configurations. I think probably there's a more elegant way to do it, but this is the way I did it. So why am I telling you this? Because one thing I've done, if you just decide to do something like this, where you want to experiment with alternate configurations, the way you might do it is you might come down here and add your own make target, right? And then you might tell it, instead of doing uploads, you might say, hey, apply my dev config, which is what I did, right? I have a script that's very similar to uploads. It's just grab it from this other folder instead of that folder, push it out to the machine. Now everything's working with that configuration. If you do that, just be cognizant that if you come back and ever run make sync, you just undid that work. Make sync really like baselines it back to the default configuration that HashiBox comes with, which is a great way actually to reset if you just want to go back to the way they had it. But just be mindful of that so that you don't like spend an hour or two going, what? I swear I have a DC3 here and there's no DC3, because they use US East 1 or West 1, West 2 and East 1. So then let's see, update SH. Let's look at that for a second. They've got this make target called update. And what does update SH do? Update SH calls this update plan. And we'll go back and look at that module, server, update, calls console update. Okay, so basically the gist is if you wanted to come in and let's say console released a new version, you could just come in here and increment, or you wanted to change the console version or anything like that, right? You could change that one line right there and call make update, and it'll reinitialize the environment with the versions that you're interested in. So that's pretty cool. And then it'll unseal at the end. Let's see. Oh, this is cool. Here's a little something about SSH related concerns around Nomad, which is basically in support of artifact downloads, I believe. And then here were a couple of custom configs that I created. And then, yeah, so that's pretty cool. Oh, another thing I did that was kind of neat, like, but I've got to find ways to kind of get them out of the mainstream. I feel like I want to take some of the modifications I made and move them maybe into a Nomad specific subdirectory. So there kind of no merge conflicts or anything like that. But I added things that were useful for me. Uh, I needed the virtual machines as they ship, the Vagrant images that come built in are for running Nomad console and Vault. They're not necessarily pre-configured to develop Nomad console or Vault. And so if you wanted to experiment, maybe be a contributor, etc., you need to go check out the scripts folder for each of the projects, find out what provisioning scripts they've got in there that they feed to their own custom Vagrant image, and then go install your Go tool chain and anything else that it might need. And so I basically codified all that here with this one-line make target called make deps, and it'll go apply that to all of the environments so that I can compile and deploy from there. Let's see what else. I've got a build script. So again, or pardon me, a build make target, which fires a build script, but basically just keep in mind the Vagrant machines I'm using as a development environment. So while sync and up and those other make targets will install binaries from the releases website, I actually want to build the executable, build the binary within the VM host, push it out to all the hosts, and then stop and start systemctl and see my code changes get reflected in real time. And so, build will do that for me. Build ent will do that for the enterprise version of the code base. Yeah, and just some more Nomad development specific make targets that probably are going to get pushed down into a Nomad specific subdirectory at some point. So, all right, I'm gonna pause there, see if we got any questions. We're almost at time, and that was a lot of rambling in the mind of Derek, but I think it hopefully gave you something useful to chew on. If you want to get started with the Hashi stack and you're not sure where to go, maybe you're not Terraform savvy yet, and you are like, man, I don't know how to go spin up a bunch of stuff in AWS. But I've been using Vagrant for a really long time, and I understand how how I might work with VMware here locally, and but I haven't really started my cloud journey yet. But I need to understand more of how these things fit together. I can't recommend it enough. Give Nunchi Studios HashiBox a try. This is what their GitHub page looks like, and they've now got this sweet HashiBox.sh vanity site. I'm not going to say the word vanity. What that sounds judgmental. What's the right word? Home on the internet. It's fantastic. Oh, we've got some questions. No, you absolutely don't need to be a member of HashiCorp to use HashiBox. This is free open source software on GitHub. You can go download it right now. It is just a kindness that these folks do to the community. So thanks. That was a great question. Let's see. Yeah. All right. So I think that is basically what we've got from the chat at this time. Yeah, Charlie's saying the QEMU provider we were talking about at the beginning has possibilities, but it's got a lot of bumps in the road. So yeah, that's, if you're not familiar with it, I wish Charlie could speak. Hey, Tasha, is there any way we could let Charlie talk for a second? Are we able to promote him to a speaking member of the team? Well, while she figures that out, I'm going to keep pointing us towards what we've got. So this is the point of presence on the internet. by the way, like they do keep it up. They added waypoint. They created this. You can see 16 days ago. Added some Discord information, so you can join them on Discord. I'm going to go do that like right now. In fact, why not, right? Oh, well, I'll figure that out. And then they've created this great, informational site with info diagrams, etc. Oh, look at that! They've got a sponsor button. Ooh, so they aren't doing it totally out of the kindness of their heart. Well, they are doing it out of the kindness of their heart, but they sure would like some ducats in their purse. So if you've got a extra couple of ducats to throw their way, go do it. I think I might do that myself. Definitely worth starring them. Let's see, can I do that? Oh, I gave them a star. I can't believe I hadn't starred them yet. I use them every day. I'm a bad social citizen. So yeah. Let's see. Yeah, that's true, Charlie. Everybody does love those ducats. Yeah. So Charlie's pointing out back to the QEMU discussion at the beginning. If you're on a x86 box, you're going to be all right. Yeah, well, there you go. Thanks for showing that, Dasha. Oh, can I do that? Let's see. For those of you that aren't in the know, Dasha is the one that actually runs the show. I just stand here and talk like a Max Headroom, if you get that reference. Charlie is pumping us full of knowledge on the woes that is the M1 scenario. So basically, you can run VirtualBox on x86 Max just fine. The M1 chip comes out, and boom, VirtualBox dies. And I believe, correct me if I'm wrong, Charlie, VMware as well. And so long story short, now there's a scramble to find a solution for how to run Vagrant on M1 Max. And Oracle, I'll let you say that. Charlie with the salty leg. Thank you, Dasha. Oh, so you can use Fusion. Okay, good. Good to know. Good to know. Good to know. I knew Mitchell had been working on hacking that way back when it first became a problem. Yeah. Cool. All right. Well, all right, folks, I am gonna stop there. I think I've done enough marketing spiel for the day for Nunchi Studios. But I'm happy to do it because they've made my life so much simpler working on Nomad. Again, if you need a fast way to some people learn by reading documentation. Some people just learn by looking at code. For me, it was like a breath of fresh air to get this all-in-one download solution that immediately explained to me in very simple terms that I understood, which was code and configuration files and scripts, how to make it all work together. What needs to talk to what? How do I configure each thing to talk to each other so that I have a fully running stack in one spot? So highly recommend you go check it out if you haven't already. Thanks for joining us again. We'll do a poll online and see what we want to do as the topic next February. Is it? Oh my gosh, it's October, so we're looking at like February will be our next meetup. It's so crazy to think it'll be 2023 when we get together again. Hopefully we'll be able to do it in person next time. I apologize, this was my fault. I was doing a lot of traveling the past week or so, all over the country, and just couldn't quite make it in person today. But I'm grateful for your time. I hope you enjoyed it and found something useful. Let us know if you did. And that's it. Thanks, everyone. Have a good night.